Okay, it's a locus question 2. Now, points P and Q lie on the parabola x squared equals 4ay, and a chord PQ passes through 0 and minus 4a. And find the locus of the intersection of the normals drawn from P and Q. Now, this question, and there's a little bit of false in it. When you draw a diagram or graph, you will see it. But we will do the question assuming that everything's okay. So just keep that in mind. So if I sort of pictured this, okay, this is a pretty standard parabola, you know, concave up, because it says x squared equals 4ay. And then P and Q, just chord anywhere. I just put that on there. And then that could be P, 2AP, AP square, and then a Q, 2AQ, AQ square. Okay? Now, it passes 0 and minus 4a. And then that is a bit of a problem because that is supposed to be down here. So it cannot pass through. So what I'm going to do is I'm going to assume this going to be there. See, guys, A is a focal length. If it's A is a focal length, it has to be positive. But A itself can be positive and negative. So put it, just think that A is not really focal length. It's the can be a positive and negative. It's a value. Just think of this value because for this question, because otherwise it won't make sense. So I'm going to put this one as a minus 0 and minus 4a. Okay, so that's the point there. And then it says find the focus of the intersection of the normal. So I'm going to draw the normal. I'm going to use red pen. So red color. So I'm gonna, that's a tangent. So I'm gonna do, see if I could do that normal from there. That's a tangent, imaginary tangent. There. Okay, so that's the intersection point. I'm gonna maybe call it T for the time being. So that's the intersection of the two normals drawn from P and Q. So this is basically what the diagram looks like. And what are we trying to find? It says to find the locus of the intersection of the normals drawn from P and Q. So again, I'm just thinking if this locus turn out to be a parabola, and then it could be, this could be a vertex and then going like this. Could be something different, or could be part of the parabola. So I don't know, but somehow we have to find the locus of this intersection point here. Okay, that's what we're going to do. So that's the visual part of the question. Now we need to get into the algebra part of it. Most of it is all algebra. Now, before we start, remember, guys, the locus is in terms of Cartesian equation, so which is x and y's. And we have these P and Q's in terms of the P and Q's, the points P and Q's in terms of P and Q. So we need to replace it eventually, those are P and Q, with x or y's. So again, we need to look for some special condition that we can use or replace with. What am I going to do? I'm going to use the chord because that's the chord that we had. So I'm just going to use the equation of a chord already given to us, which is y minus half p plus q x plus a p q equals 0. Okay, and that is going through 0 and minus 4a. So I'm going to substitute in that. So normally when we actually do this, you will have special condition in terms of PQ, like P times Q, equals a value. So then we can replace that to make it simplify the equation, the locus. So I'm going to put that in, minus 4a. This whole thing will be 0 because we times by 0, plus APQ equals 0. Now this one looks like it's going to be PQ equals something. Whereas the locus question 1, we had APQ equals a value. So now APQ equals 4a, because I move this minus 4a to here. And then I can cancel the a's, and therefore I've got PQ equals 4. Now that's my first hint, and I can use later on to simplify the equations. Most likely the parametric equations I'm going to simplify in order to find the locus in terms of a Cartesian form. So I've got that, and now we need to have intersection, guys. Intersection point. Now to find the intersection point, you need to have equation of each normals, don't you? So you have to have 2 equations of normals from at P and Q. Now we've already done this, the intersection point of the 2 normals. So I'm going to just use that. So here, normals intersect at, okay, I'm going to write the coordinates, A, P, Q, P plus Q, A, P squared plus, I'm going to write PQ plus Q squared plus 2. Guys, this was already proven previous lesson, so I'm just going to use this. So that's what I've got. Now, these are the 2 parametric equations, and I'm going to put it into x equals minus APQ and P plus Q, and then y equals a P squared plus PQ plus Q squared plus 2. Okay, before I go on, I can already simplify a little bit with this special condition we have. I can see the PQ there. I can see PQ here. So I'm going to simplify this before I go any further. So it'll be minus 4a P plus Q. Okay, so that's that. And the y equals a P squared plus Q squared, and that will be 4. So 4 plus 2, I'm going to get 6. So that's what I've got, 2 parametric equations. Okay, now I told you before, this parametric equation will eventually transform into locus, Cartesian equation, when we actually replace this P squared plus Q squared in terms of x. So I'm going to leave that one, and I'm going to work with this. Okay, so I can see there's a P plus Q and there's a P squared plus Q squared. You know, you can tell that they're sort of related. They're not equal. Okay, P plus Q whole thing square. I'm going to emphasize this again. I did that previous lesson, but it's very important that you do not get confused. They are not the same, guys. So make sure you do not use that. But we can actually use this turn into P squared plus Q squared as a tool. So I'm going to write this, P plus Q squared equals P squared plus 2PQ plus Q squared when you expand it. But if I actually take away 2PQ here, I will end up with P squared plus Q squared. So what I'm going to do now, therefore, I'm going to do P plus Q squared whole thing squared minus 2PQ will give me P squared plus Q squared, which I can substitute into here. Okay, so that's my plan. Now before I start substituting in there, I've got to do one more thing. it's here. From this parametric equation, I need to change this in terms of P plus Q, because I know I'm going to use it, I need it when I replace it here. So I'm going to change that in terms of, so minus 4a P plus Q equals x. I just swapped around. And then I'm going to do P plus Q. I'm going to make this subject is x over 4a. Don't forget the negative. So I'm going to use this. I'm going to call it 2. I'm going to use this one when I work with the y parametric equation here, because I need to replace that with this to make it into a Cartesian equation. So let's have a look. I'm going to push this one up. I'm going to do I'm going to start working on this part. I'm going to change this one because p squared plus q squared now I can replace with this. So I'm going to write it down here, minus 2pq. Please be careful you do not leave plus 6 out because it's there. And the a, p plus q is already here, guys. I'm going to replace that. Don't forget the minus, it comes with it. Square minus, now 2pq. What was a pq, guys, before? It's here, 4. So I'm going to replace that with 4 plus 6. Okay, and I'm going to expand that. Now that's going to be x squared, positive. That will be 16a squared. Okay, be careful with that. And now with this, I've got minus 8 plus 6, which is just giving me minus 2. Now I'm going to expand this one by one. When I do that, a times x squared 16a squared minus 2a. So that will give me, when I cancel this out, okay, so y equals, I've got x squared 16a minus 2a. Now, this looks like Cartesian equation. Yes, it is, but I would like to sort of tighten up a little to more familiarize the equation, which is, what I'm trying to say is we want this to look like x squared equals 4ay. So I'm going to change this one into that form. So to do that, I need to make the x squared the subject. So I'm going to move this whole thing on my left hand side, and the y goes to my right. And then I'm going to move this to the other side. So x squared 16a equals y plus 2a. And then I'm going to times by 16a on both sides, so that I will have x squared on my left by itself as my subject. And then I'm going to do 16a y plus 2a. Okay, so that is my locus, which is a parabola with vertex at 0 and minus 2a. So that's my equation, locus. So I'm going to just have a look at, I know this was a little bit funny graph to start with. So we're going to just assume that this 0 minus 4a is positive. So I'm going to assume that the vertex of our locus, which is a parabola, it's going to be positive as well. So I'm going to put that in there. So it's it was a 0 and minus 2a in here. So that's my vertex. So I'm going to do a dotted line, something like that, because it's passing through the intersection. So Eventually it will look something like that. So that is our locus.